Okay, so we're going to look at one of the sorting algorithms, in this case bubble sort. And say we've been asked to put the numbers 5, 4, 7, 2, 3 into ascending order. Okay, so what we do is we write them vertically. 5, 4, 7, 2, 3. Okay? And as we go, we are going to count the number of comparisons and the number of swaps that we have made. Okay, so I'm just going to change the colour of the pen to red. Okay, so first off we are going to compare 5 and 4. Okay, we know that 4 needs to go before 5. Okay, so we have needed to make a swap there. Now we're going to compare 5 and 7. 5 and 7 are already in the correct order, so we put down the least, so that's 5. Now we're going to compare 7 and 2. So obviously 2 needs to go before 7, so we put the least first. Now we're going to compare 7 and 3. Okay, 7 and 3, so 3 needs to go first, and 7 gets pushed down to the bottom. Each time you use bubble sort, you should find that the largest number is pushed right down to the bottom, and what we can do therefore is cap it off. We no longer need to compare with 7 anymore because we know it's the biggest number. Okay, so we made in that first pass 1 comparison with the 5 and the 4, 2 comparisons with the 5 and the 7, 3 comparisons with the 7 and the 2, and 4 comparisons with the 7 and the 3. So there were 4 comparisons in that first pass. Okay? So we're going to write first up here for first pass. How many swaps did we make? Well, we've had the 5 and the 4, there was a swap there, so that's 1. We had the 7 and the 2, that was a swap, and the 7 and the 3 was a swap, so we had 3. Notice that when we compared the 5 and the 7, we didn't need to make a swap in the order. That's what we're counting here, okay? So we noticed that 5 and the 7 were in the correct order, so we didn't need to count it. Okay, so let's go through a second pass. So now we're going to look at 4 and 5. Well, the smallest of those is 4. They're in the correct order. We've made 1 comparison, 0 swaps. Now we're going to look at 5 and 2. They're in the wrong order. Okay, so we're going to have to put 2 down first. So we've now made 2 comparisons, 1 swap. Now we're going to compare the 5 and the 3. The 3 goes first, then the 5. Okay? So here we have made 1 comparison with the 4 and the 5, 1 with the 5 and the 2, and 1 with the 5 and the 3. So that makes 3 comparisons in total. Okay, and 2 swaps. And as was what happened with the first pass, 5 has now got pushed down to the bottom, so I can now cap 5 off. There we are. And I can write that was my second pass. Okay, so now I can keep going. Now I'm going to compare the 4 and the 2. Okay, 2 goes first. Then I'm going to compare the 4 and the 3. There goes the 3. And we've got the 4. 5, 7. 4, the largest number, has been pushed down to the bottom. Okay, so I can cap it off. We have made there 2 comparisons and 2 swaps. Okay? Now, we know that these are in order, okay? But imagine a computer. The computer doesn't know. It can't tell. It needs to make one further comparison. So it needs to look at the 2 and the 3. Sorry, I've forgotten to put third up there. Put third. So we're going to look at the 2 and the 3. They're in the correct order, so 2 needs to go first. 3 goes second. 4, 5, 7. Okay, so we've made 1 comparison, 0 swaps. So once the computer has gone through the list and it has made no swaps in that pass, okay, then it stops. So what we've got, what we can do is we can count the total number of comparisons and the total number of swaps. So the total number of comparisons is 4, 7, 8, 9, 10. And the total number of swaps is 3, 5, 7. Okay? And that is how we use bubble sort.